Welcome to lecture 11 of module 1 in database management system. So today also we are continuing with the topics related to ER diagram, and today we are going to discuss about participation constraint and also about weak entity type. So in the last class we have talked about we have started with the constraints of binary relationship. Okay, there are two types of constraints on binary relationship types. The first one is cardinality ratio. The cardinality ratio we have already discussed: 1 to 1, 1 to many, many to 1, and many to many. So all those cardinality ratios we have seen. And next one is the participation constraint. Okay, so this topic is actually telling what are the constraints that we are providing in a binary relationship type. Okay, in a binary relationship type, what are the constraints that is being provided? First one is cardinality ratio, next one is participation constraint. So today we are going to start with the participation constraint. Participation constraint. This constraint specifies the minimum number of relationship instances that each entity can participate in. So let us explain this concept using an example. So let us consider this ER diagram. Here we are having two entity types, employee and project. Okay, and here the relationship type is works on. So employee works on project. So here before explaining, I will give the cardinality ratio. What will be the cardinality ratio for this ER diagram? Let's check it. So each employee can work on how many projects? Each employee can work only on one project, right? So each employee can work on only one project. So a single project can be assigned to many employees. Okay, so here the cardinality ratio is many to 1. Okay, so I will just write down the cardinality ratio, which is many to 1. Okay, which is the cardinality ratio. Clear? So each employee can be assigned to a single project. A single project can be assigned to many employees. Okay, so the cardinality ratio is many to 1. Now we are coming to the participation constraint. So here this project entity can exist only if it is assigned to if it is assigned to an employee. That means that this project entity can participate in this relationship only if it is assigned to an employee or multiple employees. At least one employee must be the part of this project. Only then this project can exist in this relationship or can have a relationship with the relationship with the employee entity. Okay, so the minimum participation instance of the project is 1. Okay, so there must be at least one employee doing a project, only then he can participate in this relationship. So the minimum participation here is 1. Now let us look at here an employee, and in employee in a company, it is not mandatory that all the employees in the company should be assigned a project. Some employees will not be assigned project. Okay, so some employees will not participate in this relationship. Some employees will not have may not be having project. Suppose in IT companies and all, if the employees are placed in bench, they will not be assigned any project. Okay, in such case the employee will not be assigned any project. Okay, so the employee will not have any project here. So the employee will not have any relationship instance with the project. Okay, so the minimum participation here of the employee with the project relationship is with the project is 0. Okay, so that is what this statement says. The minimum number of relationship instances that each entity can participate. So here the project's the minimum number of relationship instance with the employee is the what is 1. At least one employee must be there. Only then this project can exist. Otherwise this project cannot have the relationship with the employee. Okay. Here in the case an employee, it is not mandatory that all employees must be assigned the project. There can be employees who are not assigned project. So the minimum participation of this relationship instance is 0. Here it is 1. Okay, so this is the definition of the participation constraint, the minimum number of relationship instances that each entity can participate in. Okay, it is also called, this participation constraint is also called minimum cardinality constraint. It is also called minimum cardinality constraint. Clear? So this participation constraint is classified into two: total participation and partial participation. So total participation is the concept that I have just explained here. Total participation means that every entity in this entity type called a project must participate in at least one of the relationship type works on. That means that if suppose it is having 3 projects, project 1, project 2 and project 3, and each of these projects at least one employee must be assigned. Okay, so project 1 must be assigned to one employee, project 2 must be assigned to another one employee, project 3 must be assigned to another one employee. Okay, so all these entities in this project entity type must participate in the at least one relationship in the relationship type works on. Okay, so such participation is called total participation. Okay, so total participation is actually represented by double lines in ER diagram. Okay, that is why it is given in double line. Okay, in the previous classes on all we have not seen this concept. Okay, double line concept we have not seen. So this double line is the representation for total participation. Okay, so which entity is having this total participation, that entity will be given double line. Okay, now we can talk about the partial participation. Partial participation means here employees, I have told that all the employees will not be assigned project. Okay, for example, employee 1 will be assigned a project 1, employee 2 will not be assigned any project. Okay, employee 3 will be assigned project 3. Okay, so employee 4 will not be assigned any project. Okay, so in that case, so those employees, some employees or some entities are not participating in this relationship. Okay, so such participation is called partial participation. Okay, this is called a partial participation. Partial participation is actually represented using the normal single line in ER diagram. Okay, so this is the difference between total participation and partial participation. Okay, so this is the explanation for the statement. Okay, this is the statement I have just taught. Total participation, if every entity in the entity type, okay, participate in at least one relationship in the relationship type, it is represented by double lines in ER diagram. Okay, so such is called a total participation. Okay, partial participation means if some entities may not participate in any of the relationship type, it is represented by single line. Okay, for more explanation I will just give an explanation. Suppose in the previous thing we have ER diagram, we have projects P1, P2, P3. Okay, now we have employee E1, E2, E3, E4. Okay, so here project 1 is assigned to employee 1, project 2 is assigned to employee 2, project 3 is assigned to employee 4. Okay, so here what is the meaning? All the projects, all these projects, all the entity in the project, the entities are this is the entity P1, P2, P3. So all these entities are participating in this relationship, they are assigned employees. But here, so this is total participation. This is total participation. But here in this case, employee 1 is working on project 1, employee 2 is assigning project 2, employee 3 is assigning on project 3, but employee 4 is not assigned any project. Okay, so that is why, so this is called partial participation. That is why it is said like this: some entities may not participate in any of the relationship in the relationship type. Okay, such entities are called such participation is called partial participation. Okay, clear? Okay, so partial participation is actually represented by a single line. Total participation is represented double line in ER diagram. Okay, now let us see another example. Department, entity type is department, another entity type is project. Okay, they are related using the relationship type handles. Okay, so here before explaining, I will just write down the cardinality ratio. Okay, what will be the cardinality ratio? Each department can have how many projects? Each department can have many projects. Okay, each department can take up many projects. Okay, but a project can be assigned only to a single department. Okay, so here the cardinality ratio is 1:many. Okay, 1:many. 1:many. Clear? So the cardinality ratio is 1:many. Now let us see the participation. So here this project entity, all the entities in this project entity type must be assigned to any one of the department. Okay, it must be compulsorily assigned to any one of the department. Only then this project entity can exist. Okay, so this project is actually it is under total participation. Okay, this project has total participation. But in the case of department, there can be departments which are not assigned to any projects. Okay, so suppose there are projects P1, P2, P3, and there are department D1 and D1, D2, D3, D4. So project P1 is assigned to D1, P2 assigned to D2, P3 assigned to D3. Okay, so all the entities in the projects project entity type is being assigned to any of the departments. Okay, but department, some of the department has not been assigned any project. So this is partial. Department has partial participation, but here project has what? Total participation. So that is where they have given double lines. Clear? So this is explanation given. A entity project should have at least one department. Okay, they must be participating at least in one department. So the project has total participation. There can be no department which is assigned any project. So the department has partial participation. Okay, so in ER diagram, total participation is represented as double line. Okay, single participation is partial participation is given as single line. Okay, now another example: employee and department. Employee manages department. Okay, so tell me, what will be the cardinality ratio here? What will be the cardinality ratio? Each employee can manage how many department? A department can be managed only by a single person. Okay, head of the department can only manage the department. So each employee can manage only a single department. Okay, a single department can be managed by how many employees? Only one employee. So here the cardinality ratio is 1:1. Okay, the cardinality ratio is 1:1. Now we can see the participation constraint. Okay, which is having the total participation, which is having the partial participation. So here a department can exist only if there is having employees. Okay, so all the departments must be having relationship with at least one employee. Okay, each department must have at least one employee. Otherwise, the department cannot exist. Okay, so department is under total participation. Okay, so but in the case of employee, there may be many employees in this employee entity type. Okay, employee 1, 2, 3, 4, etc. In that list, only some of the employees will be managers. Only those employees can manage the department. So the rest of the employees will be normal employees. They cannot manage the department. Okay, so all the employees in this employee entity cannot manage the department, cannot have any relationship with the department. Only managers can have relationship with the department. So this employee is having partial participation. Clear? So this is having total participation, this is having partial participation. Clear? Hope you are clear with the total participation and partial participation. Now next topic, entity types. Different types of entity types. Okay, entity types, types of entity types. Okay, so entity types are classified into strong entity type and weak entity type. So what is strong entity type and weak entity type? Okay, the a simple concept about the strong entity type is that the entity type that is having one key attribute. If that entity type is having a key attribute, what do you mean by key attribute? The primary key. What do you mean by primary key? Primary key is an attribute that can be used to identify a particular record. For example, in the case of a student table, S4 CSE student table, what will be the primary key? There are attributes like roll number, name, marks, date of birth. Okay, in that, which attribute can be used to identify a particular student? That is with the help of a roll number. So roll number is the primary key or the key attribute. Okay, so such entity types are called strong entity types. So student is a strong entity type. Okay, so weak entity type means the entity type that does not have any key attribute. Okay, so strong entity type that have at least one key attribute. A strong entity is not dependent of any other entity in the schema. Okay, in strong entity is not at all dependent on any other entity. So a strong entity is having its own primary key or key attribute. So it does not need to rely on any other entity for identifying a particular record. That is why it is saying that a strong entity is not dependent on any other entity in the schema. A strong entity will always have a primary key. Yes, the strong entity will always having a primary key. A strong entities are represented by a single rectangle. Okay, so I am actually we can see an example. After seeing this example, we can come back with the explanation. So this is the figure, the ER diagram that explains the a strong entity and the weak entity. So here this is loan entity type loan, this is the entity type payment. This entity type payment is having attributes like payment number, payment date and payment amount. This loan, it is having attributes like loan number and amount. Okay, so here look at here in the loan attribute, loan entity type, see the attribute loan number is being underlined. So what do you mean by the underlined attribute? Underlined attribute means it is a primary key or a key attribute. What do you mean by key attribute? This loan number can be used to identify a particular record in this table or in this entity. Okay, clear? So let us see an example here. So a loan is related with the payment entity type. Okay, the relationship type is pay loan. Okay, sorry, loan payments is the relationship type. Okay, in this case, Suppose I am having two loans. Suppose I am having, sorry, three loans. This is the table. I am representing the loan. It is having two attributes, loan number and amount. The same thing, the same attributes is represented here as well. So here I am having three different loans, L1, L2 and N3. The first loan is of amount 1 lakh, second loan is 2 lakh and the third loan is 1.5 lakhs. Okay. Now I am representing the payment entity type, the payment table. It is having three attributes, payment number, payment date and payment amount. Okay. So look here, I am actually paying, I am having these three loans and I am going to the bank and I am going to pay, I am going to the bank on 26th May and I am going to pay the EMI or the installment on the same date for all these three loans. Okay, so carefully listen. On all these three loans EMI I am going to pay on 26th May and the EMI amount is 10,000 for all the three loans. Okay, I am going to pay all these three loans EMI of amount 10,000 on 26th May. Okay, so since I am paying this loan, all these EMI on the same day, the payment number is same, P101, 101, 101. So in this case, look at this table. How can I identify a particular record? Is it possible to identify a particular record? No, because the payment number, see here the payment number, all the values are same. Payment date, all the values are same. Payment amount is also same. So how can I identify a particular record uniquely? It is not possible. Okay, so this entity type is not having any key attribute or it is not having any primary key. Okay, so such attribute, such entity type is called weak entity type. That is why it is called weak entity type. Okay, but in this case, look at here. Here I can uniquely identify a particular record. How? Using the loan number. Okay, so L1 represents the first loan amount, L2 represents the second loan amount, L3 represents the third loan amount. Okay, so I can uniquely uniquely identify this record or this entity using the primary key loan. So loan number is the primary key. Okay, so an entity type who is having a primary key is called strong entity type. So this loan is a strong entity type and this payment is a weak entity type because it does not have any primary key. Okay, so here this payment number is cannot be act as a primary key because this is not giving any unique values. Okay, so such keys can be called as partial key. Okay, so such keys can be called partial key. The key that cannot be used to identify a particular record. Okay, such keys or such attributes are called partial key. So this payment number is actually a partial key. Okay, so in this case, how can I uniquely identify a particular payment? I can uniquely identify a particular payment only if this payment number is merged with the loan number. Okay, that means this payment entity cannot exist alone. It needs the help of another key attribute from the another entity type. Okay, so I am taking this loan number, I am attaching the loan number along with this payment number. See, I am attaching the loan number along with this payment number. So this payment entity type is actually attaching the loan number along with this along with the payment entity type. Okay, in this case I can surely identify the particular EMI payment. So first loan L1, the first EMI I have paid 10,000. For loan L2, the EMI I have paid is 10,000. For loan L3, the EMI paid is 10,000. Okay, so these two combination of these two attributes, these two attributes can be used to identify a particular record. Combination of these two attributes can be used to identify a particular record in the payment entity type. Okay, so that is why it is written here. Payment entity type can exist only by combining the primary key of loan entity. Okay, primary, which is the primary key of loan entity? This loan number. Okay, primary key of loan entity type and the partial key of payment entity type. The partial key of payment entity type. Clear? So this is called a weak entity type and a strong entity type. Okay. So this weak entity type actually exists in a total participation constraint, or a weak entity type entity type always has a total participation constraint. Okay, so total participation constraint maybe a weak entity will be always having a total participation constraint. Okay, you remember that concept. Now another concept is the identifying relationship. So identifying relationship is a type of relationship that actually connects a strong entity type and a weak entity type. Okay, a weak entity type and strong entity type is connected or linked using a relationship. That relationship name is called identifying relationship. So identifying relationship is actually represented as a double diamond sign. Okay, so double diamond sign. Also weak entity type is also represented as a double rectangle. Okay, so this is the concept of strong entity and weak entity. Clear? Now let us come back to the explanation part. Strong entity type, the entity type that have at least one key attribute. Okay, that is a strong entity. It does not depend on, strong entity does not depend on any other entity. Okay, here in this example, the strong entity is not depending upon any other attributes or any other entity. Okay, unlike a strong entity will always have a primary key. Strong entities are represented by a single rectangle. Okay, that all we have explained. A relationship of two strong entities is represented by a single diamond. Okay, the relationship that is connecting the strong entity and the weak entity is represented by a relationship of two strong entities. If two strong entities are being connected using a relationship, that relationship is represented by a single diamond. Okay, so various strong entities when combined together create a strong entity set. So when various strong entities are when they are combined, they create a strong entity set. Okay. Next is weak entity type. The entity type that does not have any key attribute. That is the main point. Does not have any key attribute. Such entity type is called weak entity type. Weak entity type is dependent on a strong entity to ensure its existence. Okay, that's the concept that we have explained. This weak entity need to exist. In order to exist, it is getting the help from the another entity, loan. Okay, so here the attribute loan and the payment number is getting attached. Okay, that is what it is saying. A weak entity depends on a strong entity to ensure its existence. Unlike a strong entity, a weak entity does not have any primary key. It instead has a partial key. Okay, instead of primary key, it is having a partial key. This is called the partial key. Okay, a weak entity is represented by a double rectangle. A weak entity is represented by a double rectangle. The relation between one strong and one weak entity is represented by a double diamond. Okay, the relationship between one strong and one weak entity is represented by a double diamond sign. Right? Okay. Now identifying relationship. That double diamond sign is called the identifying relationship. It links the strong and the weak entity and is represented by a diamond sign. Okay, so this is weak entity. We will see one more example. Let us see. professor and dependent. So professor entity, this is the entity type called professor, this is the entity type called dependent. This professor entity type is actually storing the details of a professor ID, name, professor name, the city he is staying, and his salary. Okay, and the professor dependent means a dependent is the employee or the person who is working under this professor. Okay, he may be his assistant or other employees who is working under this professor. Okay, so a professor has a dependent. Okay, so what is the cardinality ratio? It is already given, the arrow here. Okay, that is each professor can have many dependent. A dependent can work under only a single professor. Okay, so it is one to many dependents. Okay, so here see the dependent name, date of birth, and relation. Suppose a dependent is a professor, the professor is having a dependent. His first dependent name is Arun. Okay, date of birth is same, also same. Okay, the relationship is guide or the student. Okay, he is also having another same person called Arun. So two Aruns are there. Then how can we identify these record? How can we identify a particular Arun? Okay, suppose we are having three professors P1, P2, and P3. Okay, and P1, the professor P1 is having a dependent called Arun. Okay, is having the date of birth, and P2 is also having a dependent called another Arun. Okay, so how can we identify these two Aruns? So that is very difficult. So this means that this dependent entity is not having any primary key to identify these records. Okay, so this name is actually not a primary key. This is actually a partial key. Okay, so this is a partial key. So an entity type that is not having any primary key is called a weak entity. Okay, so this is a weak entity type. Okay, here the name is not a primary key, this is a partial key, but here the professor having a primary key. Okay, so primary key ID, so such entity type is called a strong entity type. Okay, so weak entity type is represented using double rectangle, and this the relationship that is connecting a weak entity and a strong entity type is called a identifying relationship. Okay, that is why it is given in double diamond. Okay, so this is the summary. The professor is a strong entity, dependent is a weak entity, the partial key is partial key of the weak entity is the name, and the primary key, the strong entity, is the ID. Okay, so you always remember that the partial key is associated with the weak entity. Okay, only the strong entities are having the primary key. Okay, so this is the explanation for strong entity and weak entity. Okay, so today we have studied two concepts: participation constraints and weak entity type. Okay, so all these concepts are very important. So all these concepts are required for while we construct a ER diagram. Okay, so our next task is to next task is our is the construction of the ER diagram. So using all these concepts we have studied till now will be used for constructing the ER diagram. Okay, thank you.